Welcome to another R tutorial. This time we're going to explore numerical data looking at row subsets. In particular, we're going to look at three functions that examine rows of the data set. If you recall, in an earlier tutorial, I had demonstrated how to explore a data frame in terms of a spreadsheet and in terms of the names of the variables using two other functions. So you can use within the RStudio environment the view function to essentially explore the data sets as it were like a spreadsheet. In this case, we're going to do something quite different. We're going to look at the first few rows of a data set. We're going to look at the tail end of that data set using the tail function. And then we're going to look at a really useful tool, which is a random sample of a few cases within the data set, because it might be possible that the ordering of the rows may be systematic. So it's a useful verification check to take a look at the data as a random subsample. And I'm going to emphasize here that it's always useful to look at the data. And I think these cases are really, or these functions are extremely useful when we look at data sets that are really, really large. Sometimes you really need a few cases and you need to do several different dips into the data. And this is a good entree into numerical data analysis. Before we get into the analysis of a new data set, I'm going to remind you that the process of downloading the data set, the R data file, and the code is identical to downloading the Titanic data set that was used to examine categorical data analysis. If you go to the course website and look at the list of R tutorials, and select the video Getting Your Data into R, I recommend you revisit this if you find it difficult to get your data into R again, because the procedure is identical. You download the data set from the problem set, which is in part 2 or part 3. It's partway down the problem set. Then once you download your scripts, your R file, your code, and your data file, then you want to put those, you want to drag those two files from your downloads folder into a folder on your desktop or some other convenient place, and preferably in the same location, because we want to have a little sandbox, a little area where we can maintain all of our project analyses in the same location. It's just good data practice. And as you can see, I've already done this. I have a little a little folder I've entitled Pop Kids because of the name of the data set in the project aims. And here we have the data file, and this is what your data file should look like. And here's what your R file should look like. So this is identical. The first time you open it, you won't have a history or this data file here. I'm going to actually delete that. That's not necessary. You typically have a history file once you open and you revisit the data file. But the first time, you should just have your script and your data file. Nothing more. And if you have any issues, revisit downloading and getting your Titanic data into R. It's the same process. Okay, we're not going to revisit that because we want to cover new terrain today. And this is exciting because what I'm going to show you are the virtues or the benefits of exploring data in this fashion as opposed to what we had done in an earlier tutorial. So let's click on the R data file and it'll open automatically in RStudio. And this is the script for the second problem set. We're going to install the package, Mosaic package in the library as we have done before. And you'll see it install. And I think it's, especially beginning, it's always important to revisit this, and we can always click our Packages tab, and you'll see here our Mosaic library is in fact called into our session. So we are good to go. I have some syntax here, some script here to load the file in the current directory. We can explore the meaning of working directories here. I just left this here because this is useful if you want to upload the data file at another moment. As you can see, I already have the data file uploaded, so it's not necessary to revisit. I wanted to take us back to our original process of exploring a data set, which is the most intuitive approach, which is to view it as a spreadsheet. And when we look at numerical data analysis, we're putting on the hat of a psychologist. This is a really interesting study, an actual study of elementary school children that asks them about their goals, as well as their rankings of 4 attributes. Their importance of grades, their importance that they evaluate with regard to the importance of sports, looks, and money. Now, at first blush or first glance, these might look like categorical variables. You could imagine that they might be independent ratings. Okay, I'll rate, grades is very important, sports is very important, looks is very important, and money is very important. But this is the virtue of looking at the data. And I'm going to show this to you not through our standard procedure of, or earlier procedure of looking at the view function, but we're actually going to look at this so-called head function. We're going to look at the first few rows, and that's going to appear in the console rather than in a separate tab. And here we see the data actually printed out in the R console. And what we see here, and by the way, this is the tail function, my apologies. So you'll see that this is actually, these are the last 6 rows of the 478 students or youth in the survey. And what you see here is that, well, these happen to be boys, so there might be some systematic reporting here. So we don't not necessarily want to look at the tail or the head, because these might not be a random sample, which is why we're going to look at the sample function after this. But what I want to show you is, it's important to look at cases sometimes to really understand the data. Let's say we didn't have a code book here and we didn't know what the data were. Well, you can look at the fact that for each row, for each child, they only assign one particular value to each of these attributes. So this child reported looks as most important, sports is second most important, grades is third most important, and money is the least important. And this child has a goal of getting good grades. And then here you have a categorical variable of the school location, a categorical variable of the type of school. It looks like perhaps actually the name of the school, I'm not sure. And the grade level, and a gender variable, which we visited in the Titanic data set, and then another numerical variable, which is age. What's interesting here is that these are in fact numerical variables. Youth are asked to rank and they're forced to rank from 1 through 4 these attributes. They're essentially constrained. They're given 4 virtues, 4 objectives, and they have to place them in order from the most important to the least important. In this sense, these are numerical data, because they're actually a ranking order of actual of their actual quantities of rankings of importance. So let's look at the head function as well. It's just the obverse of the tail function. You're looking at the first 6 rows. And you can, of course, there are some options here if you want to look at the help file here for the head function. You can look at more, fewer rows, but here you'll see just a few different cases. And here you'll see, for instance, a girl who, well, let's look at the first row. We'll look at another boy. He's in 5th grade. It looks like he's in elementary school, at a rural elementary school. His goal is sports, but he values grades, followed by sports, followed by money, and places the least importance on looks. Let's look at row 6. Here we have an 11-year-old girl who places her most importance on looks, then sports, then money, and least importance on grades. And she really emphasizes being popular. So here we have a different data set, a different environment. We are looking at the psychology of child development and of peer dynamics within schools, as opposed to the historical processes of survival and of inequalities of the Titanic. So we're using the same techniques in a completely different environment, but we're still using useful tools to examine what exactly is going on with the data. Now, because we looked at the head, when we looked at the head of the data, it looked as if maybe there wasn't really a pattern here. But what's interesting here is the last few rows. These are all 11-year-old boys from the same school, and we really want to probably really ensure that we're looking at a random sample. And this is where we invoke the sample function. And this is where we first start using this so-called assignment operator. You'll see this quite often. It's a little arrow pointed to the left. It's just a keystroke, and then a little hyphen here, typically off as a space. What this says is we're going to define a new data set of popular kids that only includes 10 kids, but that we're going to use a function, and if you notice the parentheses are highlighted, we're going to take this data set and we're going to only subset it to 10 kids. So let's create a data set of 10 kids. And I'm just highlighting this, and look at this. If we look at our environment, we have 2 data sets now. This is the neat thing about R, and why it's very different than a lot of other stat packages or things like Excel. Here we have something we can play around with. We have 10 observations, ostensibly with 11 variables. We'll take a look at that. But the point here is that we have only 10 observations of the youth here. So let's actually look at the head of this data set that we created, popular kids 10. Keep in mind, this is a random sample. So it's any kids that we could have chosen, and it'll be different every time. And we'll talk about issues related to ensuring replication when we have random samples. But it says that the object is not found because, again, this is one of those important issues. R is case sensitive. So here we see, I'm going to retype this because we want to see this in the full screen. So I'm going to widen our console a little bit, and I'm going to re-show this. So here we have a little hodgepodge of rows. We have row 15, we have row 11, and here we get a different sort of sample of youth. And what do we see here? Well, okay, so here we see the original ID. This is what the added variable when you use the sample function. I think you have options to select that or deselect that. But the important point here is this is just another way to look at the data, to look at the rows. And here you see someone, for example, who values being popular or values grades, and they rank these values in this order. So what we learn from this is potentially not patterns, but at least we get to understand the structure of the data. And this is really important in a lot of data sets when there's less documentation. And we might think that these values, for instance, are just independent variables. Well, actually, they're dependent because if we know what you report on looks, if you report a 1 on looks, then you're going to have to report a 2 or a 3 or a 4 on any of the other variables. You are constrained to rank these. So these are quantitative numerical variables. It's a ranking in the same way that you would rank a gold medalist, a silver medalist, and a bronze medalist as the first, second, and third place in a race, for instance. These youth are ranking certain values. Similarly, age is also quite obviously a numerical variable. It's something we can count. So here we have examined, and I'm going to show you actually one more thing. So here we have another data frame of a sample of 25 kids. And you can have different permutations here. The important point here is that we have to have a different different name here, a naming convention. You can call it whatever you want, but this is getting closer to what we define as an object-oriented environment. You have a global environment where you can create as many data sets as you want. You can compare these, you can look at these, you can save these. And that's where I think R has a lot of potential. And we're going to look at this a little bit more. But the point here is, through using the sample function of an original data set, we can specify the number of cases we want to view, and we can explore the data set in a way that gives us insight into the data. And we're going to explore numerical data analysis further with this data sets, looking at summary statistics as well as graphics of these numerical variables. So I look forward to sharing that with you in the next tutorial. Thank you very much.